Excuse. All right. So today we're going to do 5.5b, which just is going to cover the rest of the formulas, which we're going to talk about product to sum and sum to product formulas today. Okay, so those are the last two sets on your worksheet. And again, we're just going to do a bunch of examples and see where we get, okay? So, example 1, write this as a sum or difference. And we're given sine of, 6 times the sine of 4 theta times the cosine of theta. Oopsie. Okay, so it's telling you, take this, whatever this is, right, and write it as a sum or a difference. So right then you should be thinking, okay, I'm multiplying things together, so I have a product and they want me to go to a sum. So look on your formula sheet and see what formula fits that. Do you see the sine of u times the cosine of v formula? And then it goes into a sum. So 1/2 times the sine of u plus v plus the sine of u minus v. Just barely fitting that in. Okay, so can everyone recognize that that's a formula you have because you're having a sine times a cosine? Okay? All right, so this is a formula we're going to use. Now, the next thing you have to do is you have to identify what u and v are. Okay? So what is u? 4 theta, right? Here's 4 theta. It goes along with our formula, sine of u. So u is 4 theta, and v is just theta. Okay? So now, once you have those pieces identified, you just plug it in. All right? So we're going to get 1/2 times the sine of 4 theta plus theta plus the sine of 4 theta minus theta. And then we simplify. So now we're going to have 1/2 times, let's see, the sine of 5 theta plus the sine of 3 theta. You can use a bracket, you can use a parenthesis, it doesn't really matter. Okay? The key here is these are not like terms, right? Like you cannot add these together. This is not going to give you like sine of 8 theta. Don't do that crazy stuff, okay? Those are not like terms. They just stay separate. Don't distribute the 1/2 either. Just leave it out front, okay? And it's done. That's it. That's your answer, okay? Yeah?
Why are they not?
Okay, so it's kind of like saying, you know, sine of x plus the sine of y. Can you see those aren't like terms? Even though they're both in terms of theta, they're not the same value of theta. If they were both 3 theta or 5 theta, then you could combine them into 2 times the sine of that. But otherwise, you cannot.
Will we ever have it when they are those terms?
Yes, that can happen. In this case, with these formulas, you're not, because one's always plus and one's minus. So you're going to get 2 different values, okay? In different problems, that could happen. Okay? Yeah?
So even though they're both theta, you should do is like 5x and 3y.
Right. It's like 2 different things, okay? All right, can we move on? That one was easy, right? Good, okay. Example 2, write as a product. Okay, so we're going to do 2 of these. We're going to have the sine of 70 degrees plus the sine of 30 degrees. Yeah. Oh, the 6, I forgot about the 6. Yeah. Rewind. There's really should be like a 6 out front here being multiplied, right? Right from the original problem there was this 6. I forgot. I dropped it out of the problem. So you need to do 6 times the 1/2. So really you should get 3 times the sine of 5 theta plus the sine of 3 theta. Thank you. Sorry about that. Okay? Everyone see that? I just dropped it off my problem completely. Okay? Which that is definitely a classic mistake, right? So, maybe in that case you might want to circle it, highlight it, write it down. Obviously, I need to do some of my own advice as well. Okay?
Are you making sure that we're paying attention?
There you go, Jake. Thank you. Okay, so now this is telling us write this as a product. So this time we have a sum. We want to look at the formula sheet. We're going sum to product this time. And we have a sign plus a sign. So do you recognize the formula you should use? Sine of x plus the sine of y. Okay, it turns into 2 times the sine of x plus y over 2 times the cosine of x minus y over 2. Okay, so just like before, you want to identify your pieces before you plug it into the formula. So now this time we want to find an x and we want to find a y. So what is x? 70 degrees, and y is 30 degrees. Okay, so now we substitute it in. So I'm going to have 2 times the sine of 70 plus 30 divided by 2 times the cosine of 70 minus 30 divided by 2. You with me? Keep in mind these are degrees, okay? So you might want to write your degree symbol so you don't forget that your final answer will may need to be in degrees. So here we get 100 divided by 2, so 50. So I have 2 times the sine of 50 degrees. And then the cosine is going to give us 40 divided by 2, so 20. And then we have cosine of 20 degrees. Okay, so at that point, you're not sure if you're done, okay? Because, remember, you're not going to be given a calculator, right? So no calculator on the quiz or the test. So now we want to think about, can I evaluate these without one? So are they unit circle values? No, so we're done. If they're not unit circle values, you're done at that point. Okay, let's try this one. The cosine of 75 degrees minus the cosine of 45 degrees. Okay, so look on your formula sheet. Remember they told us to write it as a product, so we know we have a difference here and we're going to a product. So everybody see the cosine x minus cosine y formula? So we should be using negative 2 sine of x plus y divided by 2 and the sine of x minus y divided by 2. Okay. Again, first step would be to identify what x and y are. So what is x? 75 degrees, and y is 45 degrees. And now we're going to substitute it in. So I'm going to get negative 2 times the sine of 75 plus 45 divided by 2 times the sine of 75 minus 45 divided by 2. Okay, so now when we drop it down, we're going to get negative 2 sine of 60 degrees times the sine of 15 degrees. Ryan, you have a question?
Yeah, so regardless of the fact that it's cosine 75 minus cosine 45, it's still going to be a positive 45 for the y value.
Mm-hmm.
And that's for every...
For everything, yeah. The minus is telling you use the formula that says cosine minus cosine. Okay, that's the only thing it applies to. Okay, it's illegal to distribute it into the negative, or to the 45 degrees. Okay, now, at this point, we want to look at our answer. Can we evaluate any of these pieces? Are they unit circle values? Yeah, right. Cosine or sine of 60 degrees can be evaluated. So what is the sine of 60 degrees? It is a lie. Yes, 1/2 is the correct. No. It's root 3 over 2. No, you're just full of lies this morning. All right, times the sine of 15 degrees. Sine of 15 degrees is not a unit circle value, so that has to stay as is. Now we just distribute the 2, right? Giving us negative root 3 sine of 15 degrees as our final answer. Pardon me?
Never mind.
Okay. Everybody okay on these two? Any questions? Moving on. This is going to be C, so we're still with the same directions, right as a product. Okay. Now we're going to be given the cosine of x plus y plus the cosine of x minus y. Little trickier here, right? Not quite as cut and dry. So, here's the problem with 5.5. It's like, do you use, like cosine of u plus v, cosine of u minus v? Or, is this different? So the directions said right as a product. So that is a huge clue that you have to take this sum and change it to a product. So the only formulas you should be looking at are those sum to product formulas, okay? So even though this looks like something we've done before, the direction said use the product. So can you see that this is x and this is y? And now this looks like the cosine of x plus the cosine of y formula. Tricky, right? Lots of x's and y's going on here. So that formula is 2 times the cosine of x plus y divided by 2 times the cosine of x minus y divided by 2. All right. Again, you want to identify your x and y. So now x is really x plus y. And y is x minus y. This is going to be hard to recognize, okay, because it's not quite as clear as some of those other ones where they give you specific angles. Okay, so now we're going to plug it in and evaluate. So we have 2 times the cosine of x plus y. So x is x plus y, and y is x minus y, all divided by 2. Times cosine of x, so x plus y. Now when you subtract y, you really need to subtract that whole quantity. So we want parentheses around the x minus y. So far so good? All right, so now we're going to simplify. So here these y's cancel. I get 2x divided by 2. So this is going to leave me with 2 cosine of x. Here, when I distribute my negative, I'm going to end up with a minus x and a plus y. So the x's are going to cancel. I'll end up with 2y over 2, giving me just y. And that's your final answer. Same formula, but looks a lot different. A little harder to see. This is the last example of chapter 5, right now. Ready? And it wouldn't be a lesson in chapter 5 without having to verify. No, not too bad. Maybe 1, 2, 3, 4, maybe 6-ish lines, 6 or 7 lines. Okay, so you ready? This is going to be fun. It's our last one. This is an exciting moment. All right, so sine of t plus sine of 3t over the cosine of t plus the cosine of 3t equals the tangent of 2t. Okay, so you and your partner, or someone around you, talk about what you think you should do there. Decide on which side to work on and think about what formulas you can use. You don't even have to do it. Just talk it through. Like, what would you do? You'll have to communicate. You have to open your mouth and let the sound come out. So what are your thoughts? Should we work on the left? Should we work on the right? I definitely think the left, okay? So if we choose the left, then we have to then think about what formulas would we use. Because clearly this is going to be a formula because we have this 3t here, okay? So we don't just have t. So it's not like we're just going to substitute some identities like we did at the beginning in 5.1 and 5.2. So when you see something like that, you should go to your formula sheet. Now, this is easier this time because we're only doing sum to product, product to sum today, right? So that was a good indication we would probably have to use those. Come the test, it's not going to say, hey, you're in the product to sum section, go ahead and verify using that, right? It's going to say verify, and it's going to have a group of verifying questions. So it's going to be a little harder to recognize. So when something looks weird, like this 3t, you should go to your formula sheet and say, how can I use one of these formulas? Okay? So does everybody see that this is going to be a sum to a product in both the numerator and the denominator? Right? So this is acting as x, and this is y. And in this case, this is x, and this is y. Okay? Are you with me? Okay, so let's plug it in. So we're going to have 2 times the sine of t plus 3t divided by 2. Times the cosine of t minus 3t divided by 2 in the numerator. Right? Just following that formula of sine plus sine. Now I'm going to divide it by cosine plus cosine. So that's going to give me 2 times the cosine of t plus 3t divided by 2 and the cosine of t minus 3t divided by 2. Keep in mind that this is a verifying question, so we want equals tangent of 2t on our paper, shown vertically. So it was really easy for my teacher to read it and follow my work. Okay? Now, what do you see going on here? Yeah, these cancel. You see that? They're the exact same term. Everything's being multiplied. You're allowed to cancel. This is a legal move. Okay? And now we're going to simplify these. So now I have 2. Let's see, sine of 4t divided by 2 is just going to be 2t divided by 2 cosine of 2t. See the 2's on the outside cancel? So this 2 divided by this 2 cancels. Do these 2's cancel? No, because that is locked inside and is illegal to change, okay? So we're not changing that, which is going to result in the sine of 2t divided by the cosine of 2t, which is just tangent of 2t, which is exactly what we need. Just like that, easy. In my opinion, these are easier than what we did at the beginning in verifying, right? Like there is one formula to plug in. It's cut and dry. There's no crazy identity substitution going on here. It's clear what you should do once you see it, but you have to recognize it, right? Okay, any questions?